So, okay, in the last session, we have covered the part of the some important part which is required for the design of industrial shed. So it means we have seen the particular uh, what we have to design in the industrial shed, then what are the various loads acting on the industrial shed, then what various types of the industrial shed, then in the particular wind design of wind force, what we have to consider. The in the IS 875 part 3, there is a various factors K1, K2, K3, K4 factors that are given in the IS 875 part 3. That part we have covered. So here we will see the one of the example of the design of industrial shed, and you will get how to design the industrial shed by the here theoretically, and same whatever load we have calculated, that way that load we will put into the or input give to the software, then we will know the how this industrial shed, or how what are the particular members we can use the various shapes that we will get. So here one of the problem I have taken. So problem is determine the design forces and design the members. So members here given, this joint is L0, L1, L2, L3, L4, L5, L6. So for the particular joints we have given L2, L6 naming. Then here U1, U2, U3, U4, U5 likewise. So design the determine the design forces and design the members U0, U1, U1, L1, L0, L1 of an address where access is provided, and it is located in the city area of Nasik. Assume center to center spacing of a truss 4 meter. Assume self weight of purlin 100 Newton per meter, weight of bracing 80 Newton per meter square, and weight of AC sheet 130 Newton per meter square. So this is the given data. Take rise of truss is 3 meter. The length of the shed is 38 meter and width is 18 meter. And consider design the life of 50 years. Height of building up to the eaves is 10 meter. It means up to the bottom support height of building is 10 meter. So this is the given data. Now by using this given data, we have to determine the forces acting on a particular member, and we have to design the member. It means by the force we have to design this particular member, that we will see in the one by one. So this is the problem statement. So now, so first we have to calculate the truss geometry. So what are the truss geometries? The truss geometries, it means we have to calculate the inclined length. So here vertical height of truss is given, span of truss is 18 meter given, height of truss is 3 meter given. So this inclined length, it means L0 to U3, this is inclined length, and U3 to L6, this is another inclined length. So that inclined length we have to calculate by using this particular span and height. So how to calculate? So L0 U3, L0 U3 is the inclined length. How to calculate this? So is equal to under root of L0 L3 square plus U3 L3 square. So if you see here, under root of, it means this is the right angle triangle. L0 U3 L3, this is the right angle triangle. It means we have to calculate this L0 L3. So if we take the under root of L3 U3 square plus L0 L3 square, we'll get this inclined length. So this is so easy. How to calculate this length of principal rafter? By taking the under root of these two length. So here we got the 9.48 meter. 9.48 meter length of the principal rafter. Then length of each panel in sloping. Now, if you see here sloping, so L1, U1 is one chord, U1, U2 is another chord, U3, U2, U3 is one more chord. So here the inclined length we have divided into the segments. One segment, another second segment, third segment. So likewise, we have connected the inclined length in the 3-4 segments. So here, if you see L0, U1, U1, U2, U2, U3. So there are how many panels are there? 1, 2, and 3. So there are 3 panels are there. So, and that we have to assume how many panels provided. That is depend on the us as a designer. So here 3 provided. You can provide 4 also. So here by 3. So each panel length is 3.16 meter. It means this L1, U1 length is 3.16 meter, U1, U2 is 3.16, and U2, U3 is also 3.16 meter. So in this way, we have divided this inclined member into the 3 panels. So similarly, opposite side also. This is one side, this is another side. So for the both sides, we can provide these panels of a size of 3.16 meter. Then inclination of the principal rafter. It means theta. So here written, if you see here in the image, theta is given. So this is the inclined angle. We have learned in the design of steel structure also. Okay. So inclination of principal rafter theta is equal to tan inverse of 3 by 9. Tan inverse of 3 by 9. What is 3? 3 is the height of building and 9 is the half width of the truss. So total 18 meter span is there. So 18 by 2 is up to this L3 is 9 meter. So 3 by 9 of tan inverse, we will get the value of theta. So theta is equal to 18.45 degree. Then length of each panel in plan. So we have to multiply the plan area. So how to calculate length of each panel in plan? So this inclined length into cos of theta. If we take this inclined length and not U1 cos of theta, we will get the length of this inclined panel in a plan. So that is the 2.99 meter. That is 3 meter. So how to calculate plan area? So area A is required. So plan area is equal to plan length into spacing of truss. So plan length we have calculated, that is the 3 meter, into spacing of truss is 4 meter. So plan length into spacing of truss, we will get the plan area which is required in the calculation of the force, maybe for dead load, for the live load, or wind load. So here 12 meter square is the plan area. So this is the basic terminologies we have to calculate it initially before the calculation of the dead load, live load, and wind load. So here we have calculated length of principal rafter, length of one panel, then length inclination, it means theta, then length of each panel in plan, and plan area. This much terminologies we have calculated initially. Now we have to go for the second, that is dead load calculation, or panel points load due to dead load. So due to dead load, how much load coming on this particular truss? So that we have to calculate. So as we have discussed, so there are 4 types of load coming in the dead load calculation. So first is the weight of sheet. So here they have given to us in the problem statement. AC sheet is given, weight of purlin is given, weight of bracing is given, and weight of truss we have to calculate. So weight of AC sheet is 130 Newton per meter square is given. Weight of bracing is also 80 Newton per. So here I think weight of weight of bracing is 80 Newton per meter square is given. Self weight of truss, we can calculate it by span by 3 plus 5 into 10. So in this way, they have calculated this self weight of truss is 110 Newton per meter square, and the addition of these 3 is the total load 320 Newton per meter square. But one more load we have to add, that is the weight of purlin. So weight of purlin is given, they have given into the 100 Newton per meter they have given. So other weights are in the Newton per meter square. So we have to add here weight of purlin. So how to calculate weight of purlin in Newton? So if we multiply the spacing of truss, we will get the weight of purlin in the 400 Newton. So if you see here, initially they have added 3 weights: weight of AC seat, weight of pressing, and self weight of truss. So finally they have added total weight, total load, that is 320 Newton per meter square. Now we have to calculate the dead load in the Newton. The given load is in Newton per meter square. So we have to calculate the dead load in Newton. For the why, we have to calculate the panel point load. Means ट्रस वरती, ट्रसचे जे पर्लिन रेस्ट आहेत त्या पर्लिनच्या पॉइंटला किती लोड येतोय, दॅट वी हॅव टू कॅल्क्युलेट. सो फॉर द कॅल्क्युलेशन ऑफ पॅनल पॉइंट लोड इन न्यूटन, we have to multiply the plan area to the total load. So here the plan area, plan load is equal to total area load into plan area. We will get the 3840 Newton is the load. So after calculation of this load in Newton, we have to add the weight of purlin also. So weight of purlin in Newton is self weight of purlin into spacing of truss is equal to 400 Newton. So total final load on the all intermediate panels due to dead load is 4240 Newton, that is 4.3 kilonewton. So we have seen what is panel point, what is intermediate point. So these all points u1 u2 are the intermediate point, and L0 u3 are the end panel point. Similarly, u4 u5 use the intermediate panel point, and L6 and u3 is a end panel point. So here final load on the all intermediate panel, it means u1 u2 u4 u5, these are the intermediate panel. So there is a 4.3 kilonewton load and final end panel point. So we have to divide this load 4.3 divided by 2, 2.15. It means u1 वरती जेवढा लोड येणार आहे त्याच्या exactly half load will carry on the L0, and whatever load coming on the u2, exactly half load will be carry on the u3 point, panel point. So this is very important. So here we have calculated the wind load, sorry, dead load calculation. So now similarly we have to go for the live load calculation. So if you see here, panel point loads due to live load, it means due to dead load, how much load coming on the panel point, due to live load, how much load coming on the panel point, that we have to calculate now. Now here inclination of principal diameter theta is 18.45 degree, that we have calculated. So now how to calculate live load? So we have seen in the theoretical part how to calculate live load. So for the calculation of live load, there is two things are required. So initially we required the slope of the truss. So slope of truss is 18.45. Here we have calculated. So it is less than or greater than. If less than 10 degree, load we have to take 1.5 kilonewton per meter square of plan area, and the load, the theta is greater than 10 degree, then we have to take the 0.75 kilonewton per meter square. So now here theta is 18.45. So theta is 18.45. Then live load we have to calculate, that is 750 minus 20 into theta minus 10 degree by using this formula. So this 750 is nothing but 0.75 given in the IS 875 part 2, which is for the live load calculation. So 75 minus 20 into theta 18.45 minus 10. So 581 Newton per meter square is the live load acting on this particular industrial shed. So this load is acting in the form of Newton per meter square. So now we have to calculate the panel point load. For the panel point load, we have to calculate the load in the Newton. So how to calculate load in the Newton? So the final live load on the each intermediate panel is equal to live load into plan area. So this is the Newton per meter square. If you multiply the area, so we will get the load in the Newton. So plan area is nothing but 4 into 3. 4 is the spacing of truss and 3 is the length of one panel. So in this way, the live load acting on the panel point is a 7 kilonewton. So intermediate panel, as we have seen, intermediate panel means U2, U1, U2 and U4, U5. These are the intermediate panel, and live load on the end panel. So 7 by 2, 3.5. So here we have seen U1, U2, U4, U5. These are the intermediate panel, and L1, L0, U3, L6. These are the end panel. So here live load calculations are over. Now next is the wind load calculations. So this is as per our earlier discussion. So very critical load combination or load we have to consider on the industrial side, that is the wind load. So how to calculate wind load? That procedure also we have seen. So now here we have to follow the things. So as in the problem statement, they have given the life of industrial shed is a 50 years and the location of industrial shed is in Nasik. So two important things are required while designing the or calculation of the wind load. The life of building or industrial shed is needed, and location of industrial shed is also needed. So location of industrial shed is Nasik. So now we have to go in the IS 875 part 3, where the basic wind velocity is given. Why Nasik is given? So depends on the region, we have to take the basic wind velocity. So for the Nasik, in this particular table, they have given. So for the Nasik, this conclusions we have done here by using this 50 years life and Nashik region. So VB is a 39 meter per second. So generally for our Pune region, 39 meter per second is a basic wind velocity. Pune region includes nearby Pune area. It means of our western Maharashtra, or Nashik is near to the Pune. So there is also 39 meter per second VB, and that VB we can calculate by in the table number 3 IS 875 part 3. Then K1, K2 and K3 factor we have to calculate. So K1, K2 and K3, we have seen this. What are these factors? Permeability factor, risk factor and topography factor. So K1, table number 4, K2 by from the table number 5 and K3 from the table number 6. So how this or why this required K1, K2, K3? Because VZ is the design wind speed. So design wind speed is calculated by using the K1, K2, K3 and VB. So K1, K2, K3, these are the factors, and VB is the design wind speed. So 39 into 1 into 0.88 into 1 is equal to 34.32 meter per second is the design wind speed. From the design wind speed, we have to calculate the design wind pressure. So how to calculate design wind pressure? So PZ is equal to 0.6 VZ square. So 0.68 into VZ is a 34.32 square. So 706.71 Newton per meter square. So this design wind pressure is a 706.71 Newton per meter square, and this is called as PD. So 0.706 kilonewton per meter square. So this is the basic calculation of the wind loads. So now we have to calculate the coefficients, or we have to take the coefficients, wind coefficients. So for the particular area, our wind coefficients are depends upon the height of building and width of building. So here height of building is a 10 meter above the ground, and width of building is 18 meters. So H by W ratio we have to take. So in the theoretical part, we have seen the one of the table in this given H by W ratio. For this particular H by W ratio on the page number 16, IS 875 part 3, the coefficients, external and internal coefficients are given. External coefficients are given. So H by W ratio we have to calculate 10 by 18, so 0.55. So 0.55, for the 0.55, the external coefficient CPE for the condition of condition and theta 18.45 degree, table number 2A. So here 18.45 degree, it means the 18.45 degree is in between 10 degree and 20 degree. So for this, when the wind angle at 0 degree and wind angle at 90 degree, it means wind parallel to ridge and wind perpendicular to ridge. So depend upon this windward and leeward coefficient. Windward, it means in the direction of wind, and leeward, it means exactly opposite direction of the wind. So when the wind parallel to ridge, at that time windward and leeward coefficient we have to take. Wind normal to ridge, at that time we have to take windward and leeward coefficients for the 10 degree and 20 degree. And our slope is 18.45 degrees. So here, this by interpolation we have calculated this bold. If you see here for 18.45 in the bold, the coefficient we have finalized by using this table number 2A. So by the calculation of this coefficients, now these coefficients we have to consider while designing the while calculating the designed wind force. So here, how to calculate design wind force? F is equal to CPE minus CPI into A into PD, as we have discussed this formula. Now CPE we got, external wind coefficient we got. Now internal wind coefficient CPI, I is nothing but internal, E is nothing but external. CP is the wind pressure coefficient. So now CPI we have to take, internal coefficient we have to take. So the internal, as we have discussed, the internal coefficients is depend on the permeability. So permeability, and it means flow of air inside the building. How much flow of air inside the building? So generally we are taking the flow of air plus minus 0.2p. It means plus is the it means positive pressure, and minus is nothing but the negative pressure. Negative pressure means the building is lifting, that negative pressure, and building is a downward force is nothing but the positive force. So 0.2 is the internal pressure coefficient. So now here area, A, capital A area required. So area, how we can calculate? So area is calculated by the span of truss into the your length of panel. So by using this formula we can calculate the area. It means on which area your wind load is active. So now PD we have calculated. So now we have to calculate the total load, total wind load on the panel. So total wind load on the panel is now 0.8 minus. Now interpolation we have did, and the load is calculated by using this formula. F is equal to CP minus CPI into A into PD. So 5.32 minus 5.32 kilonewton is the load on the panel. Then wind load of the panel for the leeward side. This is windward side, this is leeward side. So this is minus 8.86. It means these two forces are negative. It means your building is lifted due to the wind force. Your building will be lifted. Upward pressure will be acting inside the building. So that the negative pressures are here coming, or negative load is coming. So final wind load on the intermediate panel is a minus 8.86 kilonewton, and final wind load on the end panel is the 4.46 kilonewton. So now if you see here pictures, so we have calculated this particular wind loads, particular dead load on the panel point, wind load on the panel point, and live load on the panel point. So this first picture is indicating the final dead load on the panel points. It means we have calculated loads 4.3 kilonewton on the intermediate panel point, and 2.15 kilonewton is on the end panel point. So the first image is showing the dead load calculations, or dead load acting on each panel point. Second, the picture or image is showing that is the load acting on a live load. It means the live load acting on each panel points. So as we have calculated, 7 kilonewton is the live load acting on a intermediate panel point, and exactly half load will be transferred on the end panel point, that is 3.5 kilonewton. So here dead load and live load acting on a panel points, these are the two pictures are there. And then third, an important load we have seen, that is the wind load. So if you see here pictures, dead load and live load acting a gravity load, means vertically downward. Live load and dead load are acting a vertically downward, so that the arrow indications are downward side. But here if you see the 8.86 wind load and 4.43 on the end panel and 8.86 in the on the intermediate panel, these loads are shown here upward arrow. Why upward arrow shown here? Because due to the wind force or wind coefficient, your building or industrial shed is a lifting upward side. It means negative uplift pressure is creating inside the building. So that the wind force is a very important while designing the industrial shed. And after this calculation of these three loads, load due to dead load, load due to live load, and load due to wind load on the panel points, so that load we have to consider while designing the industrial shed in the software. So in the software we have to put these particular loads. So if you see here the last slide of this problem, so member forces, see design force table. If you see here table, so you have calculated the dead load, live load, and wind load. You have calculated dead load, live load, and wind load. So if you add these particular three types of load by considering the load combinations, so first load combination is the dead load plus live load into 1.5. Second load combination is dead load plus wind load into 1.5, and third load combination is a dead load, live load, and wind load into 1.5. So by considering this load combination, we have to give the input to the software. In the software, we have to put these loads, and we will get the member forces. It means the truss is there. Truss is made up of steel members connected to each other in the triangular shape. So the triangular is in the triangular shape. So the particular members are taking the tensile or compressive load. So by the load combination, we will get the tensile and compressive force of each member. So here written force in L0 U1. L0 U1. L0 is this point and U1 is this point. So L0 and U1 member carries a 66.09 tensile force. So similarly, by considering this force and by considering the procedure of tension member, design of tension member and design of compression member, we have to design this member by manually or by software. सॉफ्टवेअर मध्ये आता डायरेक्ट तुम्ही जर हे विंड लोड कॅल्क्युलेशन ऍड केले तर यू विल गेट दी actually load is coming from the by this load addition of this load, but you will get the member size. The member may be compression member or tensile member, principal rafter, sling member, strut member or tie member. Whatever members are there in the roof truss, that members are designed directly by considering the load in the software. So we have to put this load into the software. Okay, so this is the nothing but the design of industrial shed.